packaging hierarchy and identification. In warehouse logistics, the way products are packaged and identified plays an important role in the efficiency, accuracy, and automation of material flows. Most discrete goods do not travel individually, but rather as part of a structured packaging hierarchy. This hierarchy typically comprises 3 distinct levels: primary, secondary, and tertiary packaging. Understanding this layered system is essential for anyone involved in logistics, from operators on the floor to engineers designing automated handling systems. Let's begin with a simple example. Imagine a logistics center handling bottled beverages. At the lowest level, we have individual bottles, which represent the primary packaging. These bottles may be shrink-wrapped in pairs or sold individually. But in the logistics context, we typically refer to such units as pieces or items. From a warehouse perspective, this is the most granular handling level and also the most complex. Why? Because primary packaging often exhibits the greatest variability in shape, size, and weight. Whether it's a small cosmetics jar, a cylindrical energy drink can, or a rectangular blister pack for pharmaceuticals. This diversity poses significant challenges for automation and storage, as it's difficult to standardize conveyors, grippers, or shelving systems for such heterogeneous units. Next, these individual bottles are typically grouped into cartons or trays, the secondary packaging. This level is designed to bund multiple primary units together for easier handling and transport. In the fast-moving consumer goods (FMCG) sector, the term case is often used interchangeably with carton. Cases may contain 6, 12, or 24 units, depending on the product and distribution setup. Unlike items, these cases are small enough for manual picking, but at the same time large enough to support mechanized handling, such as carton conveyors or automated carton labeling stations. Then comes the tertiary packaging, the level used for bulk transport and large-scale unitization. This typically involves pallet loads, either with loose cartons or cartons stacked and secured using stretch wrap or strapping systems. Pallets follow well-established standards, such as the European Euro pallet, which makes them universally compatible with the forklifts, pallet jacks, and automated storage and retrieval systems, ASRS. Tertiary packaging also includes large, reusable containers in certain sectors, such as automotive or manufacturing, where unit loads are built using metal stillages or plastic returnable totes. Why does this packaging hierarchy matter in logistics? For one, each level imposes specific requirements for handling equipment. Pallets are straightforward to manage, both manually and automatically, thanks to standardization. Cartons, however, come in a much wider variety of sizes and structures. To handle these efficiently, particularly in automated warehouses, they are often placed onto standardized trays, effectively creating a quasi-pallet format for cases. This tray standardization is critical in high-throughput systems like automated case picking, which we'll explore in depth in a later module. Primary units, as noted earlier, are the most difficult to manage. Their small size, irregular shape, and potential fragility demand specialized solutions such as robotic picking arms with advanced vision systems, suction cups, or adaptive grippers. Moreover, the packaging material itself, glass, plastic, foil, or cardboard, also affects the feasibility of automated handling and the type of sensors and actuators required. Beyond handling, the packaging hierarchy also affects inventory accuracy and order fulfillment logic. If a warehouse only ever picks full pallets or full cases, operations are relatively simple. But in many e-commerce and retail logistics scenarios, the same stock keeping unit may be picked at different packaging levels depending on the order. One customer might require a full pallet, another a single case, and a third just 2 individual units. This flexibility is necessary to serve diverse markets, but it introduces complexity. If packaging hierarchies are not clearly documented in the warehouse management system, WMS, this can lead to ambiguities in stock visibility, incorrect picking quantities, and errors in replenishment planning. Consider this. If a system registers a stock level of 30 for a particular SKU, does this refer to 30 individual items, 30 cartons, or 30 pallets? Misinterpretation can result in serious disruptions, especially in the high-speed environments. That's why clear unit of measure definitions, accurate master data, and barcode-level traceability are essential for reliable operations. GS1 standards, including the Global Trade Item Number GTIN and the Serial Shipping Container Code SSCC, provide frameworks for identifying and distinguishing between different packaging levels. Furthermore, packaging hierarchies have implications for costing, space utilization, and damage rates. Storing items in full pallet quantities is typically space efficient and protects the goods well, but breaking those pallets down to fulfill item-level orders not only increases handling cost, but also the risk of damage and inventory shrinkage. This is especially relevant in warehouse designs, where order picking and replenishment are managed at multiple hierarchy levels. In summary, the concept of packaging hierarchy is far more than just a matter of product presentation. It is a core structural element of warehouse engineering. The ability to seamlessly transition between packaging levels, and to do so reliably and traceably, is one of the cornerstones of efficient logistics. Example. This slide provides a practical illustration of how the packaging hierarchy we've just discussed translates into real-world picking operations within a warehouse management system. Here, we see a simplified extract of order data from the warehouse management system, detailing what needs to be picked, in what quantity, and at what packaging level, which we refer to as the pick unit. Let's break down each line. Order number FR2 0201 012. This order requires 2 different items. For item number 295220, the pick quantity is 1 and the pick unit is a case. This tells the picker to retrieve 1 full case of item 295220 for customer JEB 6203. In our earlier beverage example, this might correspond to 1 carton containing, say, 12 individual bottles. For item number 223,481, the pick quantity is 2 and the pick unit is a piece. This means the picker needs to pick 2 individual units of item 23481 for customer JMB 1188. These are at the primary packaging level, the individual bottles themselves in our example. Order number FR 20201 This order is for item number 295229. The pick quantity is 4 and the pick unit is piece. Here, 4 individual units of item 295229 are required for customer RAB 0687. Order number FR 20201 014. This order is for item number 293441. The pick quantity is 2 and the pick unit is a pallet. This signifies that the picker needs to retrieve 2 full pallets of item 293441 for customer K WH3001, our tertiary packaging level. As you can see, the pick unit field is crucial. It clearly defines the level at which the item needs to be retrieved from storage. Without this information, the picker wouldn't know whether to grab a single item, a carton, or an entire pallet. This example highlights the complexity we touched upon earlier. The same warehouse might be picking individual pieces for one customer, full cases for another, and entire pallets for yet another, all for different orders on the same day. The warehouse management system plays a vital role in managing this complexity. It needs accurate master data that defines the relationship between these different packaging levels. How many pieces are in a case, how many cases are on a pallet, and so on. This ensures that when an order comes in, the system can generate the correct picking instructions at the appropriate unit level. Furthermore, this information is critical for inventory accuracy. When a case is picked, the system needs to decrement the inventory not just at the case level, but also the corresponding number of individual pieces within that case. Similarly, picking a pallet reduces the stock at the pallet level and the associated cases and individual pieces. Clear definitions of packaging units and their accurate representation in the WMS are therefore fundamental for efficient order fulfillment, accurate inventory management, and ultimately a smooth and cost-effective logistics operation.